Biology divides life into three kingdoms: bacteria, archaea, and eukarya. Bacteria and archaea are simple organisms with no subcellular compartments. Eukarya are complex with defined cell compartments and internal organelles, mini organs like mitochondria that make DNA and energy for the cell. Plants, animals, and humans are eukaryotic, as are fungi and slime molds. The archaea are the hardiest of the life forms. They're able to withstand grinding pressure, heat, acidity, and alkalinity. They can live in volcanoes, geysers, and the ice shelf. Bacteria, on the other hand, will die in extreme heat and cold, which is why we cook and freeze our food. Now, the materials appearing within these filaments are as tough as archaea. They look like bacteria, and they self-replicate. One looks like something called mycoplasma, but is not. One looks like chlamydia, but is not. And natural fibers, or filaments, would be classified as fungal in the domain of eukaryotes. But these fibers contain forms from the other two groups inside them. You're looking at a tubular fiber with self-replicating internal elements resembling bacteria and behaving like archaea. That does not happen in the natural world. So what are they? What's going on? It appears that within our bodies we now have all three life kingdoms replicating themselves. What does that make us? Are we still eukaryotes, or are we becoming something else? You could call this transbiology, a crossing of biology, the creation of hybrid forms. Materials are forming in our bodies that are not native to us, not natural, and entirely new. You can see in these pictures the tubular filaments with the branches. They're branching off. That's their self-replication. They're creating new colonies. And you can also see in the bottom picture a little bud. That's the beginning of a new fiber. The territory of things on the scale of atoms and molecules is the nano world. Science has opened up the nano universe, where incredible new creations are possible. Nanotechnology explores materials that are less than a micron in size, or from 1 to 100 nanometers. And a nanometer is a billionth, 1/1000th of a meter. Nature and biology continually work on the nanoscale, assembling proteins and building with crystals to conduct the business of life. Spider webs are an example of that. Very fine filaments with enormous strength and flexibility because they contain nanoscale crystals. So let's go back to the filaments and the structures they contain, these ones that Clifford Carnicom has found. In those unidentifiable filaments, he has observed the formation of red blood cells and submicron-sized structures. So now you've got a filament making its own red blood cells. The engineered cells, the red blood, very, very tough, withstanding excesses of heat and chemicals, indicating that they are designed to endure almost anything. He has put them in a Bunsen flame, he has poured bleach on them, acid, and they still endure. In addition, they are able to replicate, growing outside of the body in a petri dish. This is highly sophisticated technology, going on by itself, not in a laboratory. So we're witnessing red blood growing outside, having nothing to do with the bone marrow, in a petri dish, in somebody's very low-level lab. Could it be that artificial materials are being introduced into living things? Here you have, this comes from the nanotech industry. It's what I call the nanotech pyramid. You start with materials, you go up to structures, processes, and devices. Could it be that artificial materials are being introduced into us to create new processes from the ground up, which processes will override our own natural biology, our own internal systems? People with advanced Morgellons syndrome started with fibers coming out of their skin, and they're now observing very strange crystalline forms and metallic devices. The fibers became multicolored, and now they were accompanied by plaques, strange, hard little, almost like shards. People say they're like glass, and they're colored. The lesions keep emitting these things. They don't heal over or close, sometimes for years. Here are more plaque structures, even grooved metallic devices. On the right, you'll see one device, the front and the back. These images are supplied by Jan Smith of morgellonsexposed.com, who has done extensive research on biotech websites, looking for things that match what comes out of her body, and she's finding them. The fibers from her skin were from high-density polyethylene. And I'm going to read what she's written on her website. The bizarre nature of my findings suggests a man-made source. It occurred to me that if these pathogens were being bioengineered in a lab, they were made of multiple components. The mutated material might reproduce and intermittently send out a batch of identifiable debris, much like the original genetics. I call this type of debris throwbacks. It's her theory that when new life forms are made through this gene splicing and mutation, bioengineering and nanotechnology, they will self-replicate in all kinds of ways, creating different mutations in each generation. Morgellon specimens can sometimes be identified with the original spores before those mutations occurred. Jan found 3 varieties of something called Omycota fungus in her specimens, as well as something else called Dictyostelium discoideum, which is a slime mold that is a major player in biomedical research today. The material coming from her body was ribbony and motile. It was grooved and oval, very much like the Omycota spore you see here. At the bottom, where the purple arrow from the bottom is it's a diagram of Omycota. And on the upper right, you see something that came out of Jan's body that looks exactly like Omycota. The fiber strands that you see here were made of cellulose and GNA. GNA is glucans polysaccharide sugars, and this was confirmed by microscopy. GNA is a synthetic cousin of DNA. It has a 3-carbon glycerol sugar in it instead of the 5-carbon that you find in DNA. Here's a news report from April 2008 in which we are told, big headlines, GNA is DNA's chemical cousin. It's a nanotechnology building block. The Biodesign Institute at Arizona State develops the first self-assembled nanostructures composed entirely of GNA, synthetic analog of DNA. The nanostructures contain additional properties not found in DNA, including the ability to form mirror image structures. An NIH article from Japan, on research from Japan, also tells us that various conductive polymers and gold nanoparticles are entrapped within the helical superstructure of this GNA. Now, the particular sugar found in this GNA is called beta-1,3-glucans. And here you see it under what's called a Raman spectroscope, very sophisticated equipment. It looks, the microscopist who looked at this called it a sugar snake. So this is the GNA that you're looking at. When Jan's fibers were put to a high heat flame, they released what she calls a gold payload. So they dropped out this tiny little bead of gold. And here's more. The fibers that contain a head, she calls it a golden head, orbs, and they all have this payload in them. Here you have a nanoarray that she found, a couple of them in her body. Nanoarray is a tiny device used in biotech for DNA hybridization. And on the left, you see a diagram from an industry website of a nanoarray, and on the slide you can see actually 2 of them. She's marked them with red X's that came out of her body, looking exactly like this. And again, I'll say it again, the nanoarrays are these tiny devices that are used for DNA hybridization. So, I'm going to repeat my nanotech pyramid. We begin with the emergence of basic filaments, followed by more complex structures. So what processes are going on here? Are these materials combining to form devices that are working together inside us? What is happening to our biology? And remember that tissue samples obtained from ordinary people who have no Morgellons symptoms, no lesions, can be cultured to produce the very same filaments found in people with Morgellons. So we would have to conclude that Morgellons is like the canary in the coal mine, and that only some people are exuding the materials. And could that be because their bodies are rejecting it, while our bodies are integrating it? Jan's body has been sending out these plaques, colored plaques, which are hard pieces of silica. Some of them have these dots on them. They're very small. They require handling with a needle as she places them under a microscope. The plaques are fragile. They can shatter. Quantum dots, which are the colors you see, are nanocrystal semiconductors made of heavy metals surrounded by an organic shell. Now I want you to remember some of these terms. Heavy metals, okay? Heavy metals, aluminum and so forth. So these are nanocrystal semiconductors surrounded by an organic shell, but they are made of heavy metals. And Morgellon subjects are also finding this stuff. Jewel-like hexagons, faceted pyramids, crystals. Hexagons have shown up environmentally, not only in tissues, but they are in environmental fallout. This specimen is provided by Morgellons Research Group, and we have a table here this weekend, Mike and Jennifer from Morgellons Research Group. Here is a pink, ruby-colored pink layered crystal. The little inset image, you can see actually the layers in it. This was an environmental crystal found. Here is something that was not visible to the naked eye, but the woman who told me about it and sent me the photo was looking at hay. She lives in Oregon, and she was looking at a piece of hay under her microscope, and she found this bright pink, teeny tiny little crystal. You get crystals with embedded hexagons, strands that glitter. The one on the right, that's a glittering strand that came out of somebody's body. Here's a picture of tissue from a lesion with several crystals. You can see the arrows attached to it. You can see the fiber coming out from the bottom. You have combinations of wires and those quantum dots. Now here are the nanotechnology dyes. And there you see the colored plaques that have been coming out of people's bodies. One on the below has fibers attached to it. The industry tells us that quantum dots are tiny nanocrystals whose small size gives them unprecedented tunability. Okay? Tunability. The piezoelectric effect is the internal generation of a voltage when an outside pressure is applied, and vice versa. You can Google the piezo effect. The piezo effect occurs in crystals, ceramics, DNA, and certain proteins. So an example is, when you put a frequency to a crystal, it generates a voltage. And when you put a voltage to a crystal, it responds with a frequency. We call this piezoelectricity. Electricity resulting from applied compression or frequency. Recent work by Clifford Carnicom reveals that a filament culture subjected to a blue light frequency, that's 375 nanometers, resulted in explosive growth of the culture within 24 hours after the initial incubation. So he put the blue light on, incubated it for 5 to 7 days, and then it exploded into all those little fibers that you see. We now live in a frequency-filled world. I don't have time to address HAARP, artificial weather, and the enormous spread of unnatural frequencies that are affecting the Earth today. But I will say this. I came across a very well-known paper on electromagnetic fields and neurology. Neurological Function, written by Professor Ross Adey, Loma Linda School of Medicine, with the subtitle, A Possible Paradigm Shift in Biology.